So one of the really nice ways that a lot of you talked about the array, which is the same as a rectangle, is to think about if this was your original lot, and you thought about 3/4 of the lot, that we could think about the force this way and shade in 3 of them. And that the way I'll represent that is by notating like this, that this represents 3 out of 4 pieces. Do you see how I did that? And it should remind you of some of the ways that you wrote it as well. Then we're going to find 2/5 of that. So I'll cut each of these into fifths. And I want to shade in 2. So 2 out of the 5 kind of rows. So I'm going to shade them in like this. And then I'm going to mark on the diagram that this represents 2 out of 5. And notice there's a section in the middle right here. It's almost as if it's been double shaded. It's been shaded one direction, then shaded in another direction. So I'm wondering how this model reminds you of the problem. And do you understand how I wrote the 2/5 and the 3/4, how I notated it? Does that make sense? Can someone explain that? Yep, Joey?
Because the 3/4 are going horizontal, so you labeled it on the right side, and then the 2/5 are going vertical, so you labeled it on the top.
Okay. So that makes sense? Now, would it be okay with you if we use this notation to represent 3/4 of 2/5 or 2/5 of 3/4? Would that be okay? Is that one that makes sense? Yeah. Abia, do you want to say more about that?
Yes, because it shows 2/5 of 3/4. And that's what you do.
It does. It does, yeah. So we can think about this as me thinking about 2/5 of 3/4. Or you could think about this model as representing 3/4 of 2/5. Because here's my 2/5, and I'm shading in, if I think about the fourths here, 3 out of the 4 layers, right? So I can think about it in either way. Isn't that interesting that these are really the same problem? The same picture would work for both problems. Did you notice that, Nestor?
Wait, I have a question. Does the X represent of?
Does the X represent of? That's a good question. Ready?
I think so because, of is, because we can't do it in addition. Because if we do it in addition, it'll be like a different problem. Can't do it in subtraction, it'll be a different problem. But for multiplying, if you check it out, if you write it on paper and you times it all together, of is really X.
Of is really multiplying. Come on,
Of does also mean X, but I think inside this sense it means times. So we can use it as times. We're not going to use X as of, I think.
By X you mean multiplying. Was today's problem about multiplying when we talked about 3/4 of 2/5 and 2/5 of 3/4? Is there a connection to multiplying? Gio?
I think it was because we had to multiply the 2/5 by the 3/4 to get 6/20.
6/20. Good. Dale?
I think this problem was about multiplying too, because in order to do this problem, we had to find out the area of the park itself, so we can draw the playground and the black stuff.
Yeah. So and some of you, if you think about it, we kept looking for the area of the inner rectangle, and then we looked for the area of the outer rectangle. Right? It's kind of like we were thinking about that 2 by 3, and then we were thinking about that 4 by 5. And really, when we counted the pieces, it was 6 pieces out of 20. But that's kind of the same thing as here. That a 3 by 2 inside of a 4 by 5 is really still 6 pieces out of 20. That's maybe another way to think about it. So let's move into some mental math. There's no paper in front of you, no posters. Let's see if we can use this model and do some thinking about problems that aren't about a park, but they do have to do with taking pieces of pieces. So when you think you've got it, would you put your thumb up so we can tell? And just let people think for a minute about what the problem is. I'm going to start with a problem that you probably know. This one. Would you think about 1/4 times 1/3? When you've got it, just put your thumb up. Let people think. Chris, what do you say?
I think it's 1/12.
Okay, how would we represent that? Let's imagine that I were to make a model of 1/4, like this, how could I start?
Divide it into if you divide it into 4 pieces.
Okay, and you're going like this. Okay, then what?
And then divide it in 3 the other way. Like divide it in.
How do I represent 1/4? You showed me. Asked me to
And
do-
then shade in like one of the.
I'm going to shade this one in green. Good. Someone take out over from there. What would happen next, Nicole?
Divide it horizontally
Okay.
twice to give you 3,
When you say it, are you asking me to divide the whole array or just the piece?
the whole array.
Okay. Here we go. And then what?
And then shade in one of the boxes.
So here we have a picture of this part right here of 1/4, and this part right here of 1/3. And how does that help us to see 1/12? How do you see 1/12? Avia?
Because 4 by 3 for the rectangle, it's 12, and there's 12 boxes in there, and that's only one box, so it's like one box out of 12.
It's one box out of 12. Good. Let's look at another one. What if I think about this one? All right. So think about it. When you think you got it, put your thumb up. Think about it. Robert, what do you say?
I think it's 212.
2/12. Okay. Let's see if we can make an array to represent it. I'm going to use the. Okay. I'm going to use the 4ths from last time. And this time I'll shade in 2?
2.
2. Okay. Here's 1. Here's 2. In the notation, I'm going to show that this piece is 2/4. What would happen next? Felicia.
You make 3 lines.
Okay.
Through nothing. Here. And then you shade it 1/3.
I'm going to shade in.
2/3. Oh yeah.
We'll do that. And this part represents 1/3. Huh. How does that help us figure out the answer, Abia?
I just want to that you could just reduce 2/4 to 1/2, and 2/12 to 1/6.
I could reduce 2/4 to 1/2.
Yeah, and
Okay.
2/12 to 1/6.
And if I did it this way, I could think about 2 out of 12 as the same as 1 out of 6. Do you see that in the picture? Here's my 2 out of 12. Do you see 6 equal pieces?
Wait, can I ask a question?
Sure.
Why'd you shade in the whole line of that?
That's a good. Why did I shade in the whole piece? That's a really good question.
Couldn't you just shade it was 2 things?
That's a good question, Gio.
Because if you first did only the 1/3 shade, like if you erased everything and just did the box and then only split it into thirds, you would shade in the whole thing, and then you split it into 4s, you would shade in 2. So it doesn't really matter. You can shade in 2 boxes, or you can just shade the whole thing.
Do you remember in the problem we were talking about how the playground and the blacktop overlapped? And it was the overlap we were looking for? It's almost like this is the overlap of the 2 out of 4 pieces and the 1 out of 3 pieces. And where they overlap gives us this idea of 2 pieces out of 12. Or if we change the size of the piece, we could think of it as 6 pieces. You see the 6 pieces? 1, if we do this, 1, 2, 3, 4, 5, 6, and this is the one we want, so we have 1 out of 6. Another way to think about it. Here's another one. What about this? And I'm going to underline our strings in green so you see them. This was part of our notes. What about 1/4 times 2/3? Think for a minute. And then we'll make a model. Lewis, how do you think about this one?
It would be 2/12.
Okay. And let's see if we can make a model of it. Can I keep sticking with the 4ths? Why does that work? I keep cutting all these rectangles in 4ths to begin with. Why does that work, Amanda?
Because that's the first fraction that they give you in the string.
Okay, so the first fraction, notice that in the string, this pattern, I'm always starting with a fraction with 4ths in it, so I can divide this into 4ths. How many should I shade? Joey?
1.
1. Yeah, Lewis, you said 2 a minute ago. Did you change your answer? Why does 1 make sense?
1/4.
1/4. So what if I have 4 pieces and I want to show 1/4? What would I shade?
1.
1 out of 4. Okay. So I'm going to shade that one in green. And again, we'll use our notation to show that this is 1/4, 1 out of 4 pieces. Now I need to show 2/3 of that. What would I do? Lisa?
You would do the same thing you did with the other problem, but shade in 2.
Okay.
Thirds.
So we'll do the same thirds. And this time I'm going to shade in yellow. And then I'll write an initial that this is represents, if these are thirds, I shaded in 2 rows or 2 out of the 3. So in this case, I shaded 1/4 of the rectangle, which was this row right here, and then I shaded in 2/3 of the whole. But what we're interested in is 2/3 of the 4th, which is this overlap that we talked about. What is 2/3 of the 4th? Is there a way to see it from the picture? Rodney?
It's 2 of the rows out of those 3 rows.
Is it 2 rows out of 3 rows? We thought about it as the overlap. If this is a 4th and these are 2/3, they overlap in this area right here.
Yeah, I found it's from the left side, those 2 little squares out of those 3 squares.
Is it 2 out of 3?
It's 2 out of the whole thing. It's 12.
So the whole is different. Tell us why it's 2 out of 12 and not 2 out of 3.
Because there's 12 pieces all together in that whole rectangle.
Or another way to think about it is, what's the name of this piece? What size is this piece if you think about the whole array? Do you?
12.
It's a 12th, and we have 2 of them. Okay, let's keep going. I'm going to move up this way. What about a problem like this? 3/4 times 2/3. Ooh, we're fast this time. Take a minute to think. Devin, are you thinking? Yeah? Do you want to try this one?
No.
You sure? Okay. Let's see. How about Kamani?
6/12.
6/12. Okay, let's see. I'll start with my good old array. What should I start with, Kamani?
Same as the 4.
Why 4?
Because the denominator is 4.
Okay, so I'll cut it into 4ths. I want to show 3/4. How can I do that, Rebecca?
You color 3
Okay,
like blocks.
3 blocks. Showing 3. I'm going to use our notation. 3 out of 4. Now I want to show 2/3 of the 3/4. Nicole, what would I do?
Cut the box in the whole box in 3,
Okay.
and then shade in two boxes,
2 boxes.
like you know how you did with the 1/4 times 2/3, how you shaded in 2, you do the same thing.
Let me do that again. Huh. Okay. What does that tell us? Kamani?
That is now 2/3.
That is now 2/3.
What you just shade this.
You're right. Let's notate it. So let's think about this as 2 out of 3. How does that help us? Yeah. Amanda?
I'm actually kind of confused on how it's 2/3.
Yeah.
Okay. Let's back up for a second. Where do we see the 2/3? Felicia? Going across. So if you think about it as a third, and a third. In fact, I could do that. This is a third. This is a third. This is a third. I colored in kind of green this third and that third. 2 out of the 3 pieces, 2/3. There's a little bit of overlap. Notice the overlap is in this section right here. Here's the overlap where they've been shaded by the 3/4 and they've been shaded by the 2/3. How does that help us, Felicia?
That let us know that it's 6. The parts that shaded in is 6/12 of that, because the whole thing is 12, and there's 6 of them shaded in with the overlapping.
The overlapping part. So really, 2/3 of 3/4 is this section right here, right?
Yeah.
Abia, say more about that.
You could reduce it.
I could reduce it. What's another name? 1/2. Do you see in the picture how this is 1/2? Where do you see it?
Well, I say like it's 3 by 4.
Uh-huh.
That's 12 and everything. And there's 6 colored like overlaps. So that's
Okay.
6 and 6 now.
Okay, I have one more for you. Here's one. What happens if I do this? What happens if I do this? 2/4 times 3/3. Think for a minute about this. Maybe this isn't as complicated. Lewis, what do you say about this one?
It's 6/12.
It's 6/12. Okay.
Like it's 3 and 3, so
3 3s is 1. So another way to think about this problem is 2/4 times 1. What's 2/4 times 1? Same meter? It's a half. Huh, interesting. Is there a connection between this problem and the problem, another problem we've done? Nestor? It's the same answer as the other one. What happened between this problem and that problem? See if you see a connection. Rodney?
It's the same thing because 2/4 is like a half, and if you do 2/4 times a whole, which is 1, which equals 2/4, which is the half, and the other problem with 3/4 times 2/3 equals 6/12, and 6/12 is a half, so it's like a string.
It's like a string. Okay. I noticed that in all of these problems, I hope you noticed I used fourths and thirds. In this problem, as numerators, I used a 2 and a 3. In this problem, I used a 3 and a 2. But I did something different. Did you see what I did? Dale?
From the problem that you just said before, if you look diagonally, like diagonal across from it, you could place the 2 where the 3 is.
I could place the 2 where the 3 is.
Yeah.
I did some switching, huh?
Yeah.
Lewis, what was
the numerators.
I flipped the numerators. That's a nice way of saying it. I actually kept the denominators the same. So we know we're going to have a 3 by 4 rectangle, and I flipped the numerators. Let's draw an array and see what it looks like. So if we think about 2/4 times 3/3, and you said that was the same as 1, I could divide the rectangle into 4 pieces, and we'll shade in 2 out of the 4, and we'll notate that like this. And then, as we've done in the other rectangles, we'll divide this part into thirds. And now I want to show 3 out of the thirds, all thirds. So I'll think about this piece. In other words, the whole thing. So, and I can note that this is 3 pieces out of 3. So in fact, when we talked about the overlap, it's this piece right here, which is a 2 by 3, or 6 pieces out of 12. And what's cool is that, as you said, we swapped these numerators, the 2 and the 3 seem to change places. But in the arrays, we still end up with a 2 by 3 rectangle, and it's still 6 pieces out of 12. That's pretty cool. That's really neat. So I wonder if you ended up with a problem like this. If there's a way to think about these switching numerators that might really make this problem a lot easier. So that's in fact what we'll do. I'd like you to go home tonight, and I'll give you graph paper, and I'd like you to make an array of 3/5 times 5/8, and think about this idea of switching numerators, and see if that might make this problem, which isn't so great, is a little messy, if we could make that much easier. So that makes sense? Let's do 3/5 times 5/8. You'll illustrate it, and see if we can build in this idea of switching numerators, which would end up as the same picture.